It gives the current distribution at that frequency.
Yes, yes,
C'est
exactly.
seulement
So if you
3.
move it to,
C'est
so
seulement
if you
3
try
qui...
switching to 20 meters, and it should the first
Exactly, good
Yeah.
idea.
That's why they,
Or halfway maybe.
Yes.
Il montre les éléments utilisés.
So like,
That's why they use it on TV antennas, because you can cover
Yeah.
400 megahertz.
That's right. So let's put it at 20 meters.
So now you can see that of course the end elements are used.
Yeah.
But actually, even if for example 3 elements are used, they are too close together to be equivalent to a 3 element antenna.
okay, so you probably have less gain with 20 meters, is that right? Can you see?
We'll see. A little bit.
A little
No,
bit less?
no.
Or about the same?
Yeah, about the same, yes.
Et il n'y a pas beaucoup de courant sur les éléments les plus courts.
Yes, but what you understand, even if you are much current on the element, but the elements are very close, you don't have an effective gain.
No.
Because the current is not the only solution. You also have to have
The resonance.
the distance. Okay, so that's the last one I wanted to see you. Now we are
Quick
going to...
question on the log periodic. My recollection with TV antennas is it's not fed at the point where you're feeding this one.
Yes, but single antenna are more complicated. It's not obviously a real log periodic.
Okay.
I have to see which antenna you are.
Okay, but in this particular example that you're giving, if you change the feed
No,
point,
because
what
then
can
they
we
use the
expect?
wideband antennas with large elements and.
No, but for this example, if you change the feed point, what,
No, because a low periodic antenna, the particularity to have
Okay.
fastly growing elements. On a TV antenna, you have not that.
forget the TV, this particular one here,
Yes.
if you feed it elsewhere, is it necessarily fed at the end?
I'm not sure that it would work there because in this case the phase will
Okay.
move on to the
Maybe either side would be the
yes.
same.
Yes, yes. Perhaps you can feed it there,
Oh, I see.
but I'm afraid the impedance will be different.
Something to try.
I don't know. Okay.
Right, so
Something
log
to try.
periodic generally mean that they're all actively fed, or is equally called log periodic if you have a logarithmic array of passive elements?
Yes,
Still
yes.
called log periodic in both cases?
Yes, some antenna with passive elements are called log periodics because there is a I don't know.
Okay.
Honestly, I don't know. Perhaps, but I'm not sure. Okay, now we will work on short distance antenna because until now we have worked on long distance antenna dates, but of course in some cases we can have to use closer contacts.
Okay.
So the first thing I want to show you is we will go back to HFTA, but not to work with it, just to show the statistic inside it. I'm sorry, but today my screen is in 2 parts. What you can see and what you can't see. So I am bringing you the, okay. If I go to HF, hold on. HFTA. So I'm going to the statistics for from Quebec to USA. It's VUS. You can see it. So I open it. It will be open on my notepad. I'm bringing you the notepad. Sorry. Okay, and that's interesting because you know the HFTA statistics soft files are very easy to read. It's a simple ASCII field that you can edit. And what you can see, you know, HFTA is limiting is limited to 35 degrees in takeoff angle, but actually you can see that if you go on higher angles, you still have some signal on some bands. And for example, on 10 meter and 15 meter, we still have of course some some high takeoff angle or arrival angle. Because of course the USA is very close to us, and statistically there are some closer states. And then you can see that on as high as 60 degrees, you still high 3%, 5% of. So the sum of that is close to 30%. So we can say that on 10 meter, 30% of the waves are coming between 45 and 60 degrees. Okay? So that can be useful if, for example, on the field day, to have also antennas able to receive high angles. But high angles is not a big deal, because as there is only one bounce on the ionosphere, there is low losses, and generally the signal is very strong. So even if your antenna is not optimized for that, that's not a big deal, because you are often receive strong signal. But it's good to know. It's good to know. And it's good to know that you are able to look at the statistics directly using the notepad, and not only using HFTA. Okay, I just wanted to show you. Now, what we will do now, we are coming back to M.A.R.C, and I propose you to simulate an inverted V, but we have not much time, sorry. And what we do, we will load an existing file. Sorry, I'm coming.
We go back to M.A.R.C?
Yes. Yeah, because it's not because we are working on low distance antenna, but
Oh, load this, okay.
low distance. Yes. So you open M.A.R.C, and I think that in somewhere in the HF beam, HF simple, perhaps we should have no. No, there is no inverted V there. I think it's HF simple.
Dipole, yeah.
Dipole, yes. Voilà, inverted V. I don't know if I just want a very simple one.
INV web or INV 40?
INV lambda?
Yes, but this one is fitted there, but that don't change much. If you go to the geometry, there are just simulating the line with some segments, because they are using parallel lines to feed it.
Mm-hmm.
Whatever, it's not a big deal.
But remember we modeled one?
Yes, yes.
Can we use that?
Yes, you can, but I did not store it, so.
Oh, I saved it.
Okay, but whatever. But the interest is to see how it is working. So we go to geometry to check the height. So it's basically very low. That's what we want. So it's between 3 meter high and. Okay, so let's calculate to see how it looks. Wow, that's interesting. So you see when the dipole is low, you have a maximum of radiation at the high angles. So many people have decided to use those antennas for short distance communication. And actually any antenna which is low is able to make high distance communication. But as you can see, the gain is not very high. You see, and we will see later that that could be diffused.
Why does it, if it's setting that equals 0, oh wait a minute, that's 0 dB, and that's the outside of
Yes,
the left-hand
yeah,
circle. It doesn't show it there because it doesn't reach it in that slice, basically, right?
What a difference, just lifting it 10 meters.
I don't understand.
lever,
Ah.
tirer, ça fait une machine.
Ah, yeah, yes, but the goal is to make short distance communication. But that's a good idea. I will save my the plot. I call I'm not sure that I did that file. Save far field, ok. Alors on va mettre low. Now I simulate higher. Let's say 20 meters. Okay, and now I make a comparison. I don't know which 8 it is.
A lot more direction.
Yes. But I'm not sure that's it. Yes. So, that's not normal. There is a problem there.
Mais là, 10.
No, but the profile is not good.
Essaye à 10, par exemple. À 10, ça...
No, but it's because it's not on the right direction. Perhaps I could turn it by. But a limitation as a man, I can turn that.
You can rotate.
So in the geometry, I think I can turn it by 80. That's yes. Around like said. You have seen what I did?
What did you do?
Yes.
Using tools.
Yeah,
Sorry. Here you are the possibility to rotate the geometry. You did that. You say how you want to rotate it, and you recalculate the coordinates.
you put 90?
Yes, I put 90. So this way, I prefer that.
Not as dangerous as
Okay.
the
So
one that
now
hit enter.
I will take my yes, but I'm afraid that the one I have saved is on the wrong direction.
How many feet you have it in the air, Gilles?
Now it's 20 meters.
20 meters?
I will save that. That say far field. Invertedly, the limiter to.
No, let's see this thing. Oh. Rotate.
So I
Minus.
go back to calculate. I go down to 0. Start. This way I will see what I want to see. And now I can compare. Okay. Yes, that's what I wanted to see. So we are here. We are the pattern of two V inverted V. One is the low one, and the other one is the high one. Okay. So you can see that, of course, the high one is far better for the dates, because the dates is between 0 and 10 degrees, so that's the place interesting for us. But we can see that it's not obvious that for low distance, the one is better than the other, because we saw on the previous statistics that everything for USA was working between 40 there and 60 degrees. You see? So the said low distance angle are there. Then the low dipole is helping in this case, you see, because we have a hole, a notch. With, so that of course it's better to have that antenna. Another feature, especially on 40 meter, is for receiving. When you in USA, most of the time you have storm somewhere. You have storms, especially in the central USA. And central USA for 40 meter is exactly the first one skip from us. You know, so we on 40 meter most of the time we have many QRM, and the band is very noisy. According to me, the noisiest band of the ham bands, the 80 meter, the 160 meter is less noisy than 40. I guess it's because of this distance from the storms. And then, in this case, it's very interesting to have a good rejection of the low angles, Because the low angles is the angles from which is coming the QRM.
That's where the noise comes
Yes.
from, the low angle.
Yes, because if a storm is very close, of course you will have this coming angle, but most of the time they are coming from a far distance.
Well, there's a lot more of them at a farther distance than that are closer to.
Yes. So it's the situation is reversed. You have the QRM coming from the X, and the voltage signal coming from low